So which means we completed 2 units, A and B. UCM we had completed. Properties of UCM.
Yes.
We said that the body undergoing UCM experiences centrifugal force. So let's say the object is undergoing UCM, it experiences centrifugal force towards the center. Right? This is what we learned in the last class. Okay, so it acts towards the center, right?
Yeah.
Then we have to compare it with another force, centrifugal force. Okay. And we have to also discuss the nature of this force. This is the real force actually.
Fictional force.
And this is fictional or virtual force. Virtual or imaginary. So sometimes it is referred to as virtual force, imaginary, or fictitious force. Fictitious. Okay. So we will understand this with the help of the merry-go-round example. I had given you that example. That also given?
No. Yes, no.
Not here. Maybe you're delusional. I had already discussed. Had I discussed, let me come from boys' side. Have we discussed? No, it's not. So, okay. So, it happens with me also. I argue with people when I'm proved wrong. So, that's why I checked.
Sir, I think you
Because when I go from class to class, no, the lecture ends.
Sir, you had drawn the diagram, but you had not.
Then I walked out.
Yes.
So what happens? Every lecture ends at a different topic. Okay. So I am also confused. So I have to get it validated from here. Okay. So now let us say this is the merry-go-round. Is it moving circular? So let's say this is the merry-go-round wheel. So the plane of the board is vertical. This is how. Imagine the board is like this. So you're seeing the top view, hanging on some drone, and you're watching from here. Okay. So imagine you are person A here. You're sitting at the center of the merry-go-round wheel, and you are holding a ball tied up with a string. Okay. So there is a ball. So this is the string. So once the merry-go-round starts moving in this direction, the string which was initially loose will become taut or tight.
We discussed this.
We discussed this. Then what is remaining?
Sir, I was my concept is still not clear about centrifugal.
Okay, so let's do it again. I think we did it in the last moments. Let's do it again.
Yes.
So this string which was loose will become taut, T-A-U-T, or tight. So why it is tight? Is it because the ball is going away?
No, the ball is still remaining the same distance. So it is.
It is gaining speed,
So what is happening is there is a
maximum
friction.
distance.
There's a friction. So when the table is turned, table takes the ball with itself, and then it tries to move in this direction, right? Inertia. So it is moving in this direction, perpendicular to the radius. That's how it becomes taut, not because it is going away. Okay. So now, and this guy is like sitting in front of the ball, so it is rotating like this. He is seeing the ball always in front of him. So for him, the ball is stationary. Correct? Now imagine somebody standing outside. So now this is another observer. So how he sees the motion of the ball?
Circular.
Circular motion. Ball is following this path. So now he is familiar with circular motion. He says, okay, ball is moving in a circular path because of the tension in the string, right? So this centripetal force is in the form of tension in the string. Okay? So centripetal force is a general term. Now if the planets are moving around sun, there is no string between the planet and the sun. And how the planet is revolving? This is due to gravitational force. So there the gravitational force is acting as a centripetal force. Electron revolving around nucleus. So electrostatic force between the charged particle. So the nature of centripetal force will change. Okay. So now, so when a car is moving on a circular path, then what is the centripetal force? Is car tied to a string? No. But it is moving in a circular path.
Mechanical motion. What's the word for it?
Frictional force. Friction between the tires of the car and the road. So it is friction. Okay. So some nature of centripetal force will be there, either friction, tension, gravitational, electrostatic. Okay. So he says, okay, so there is a centripetal force. So this is a real force. Because he knows that this is undergoing circular motion, तो centripetal force तो लगना ही पड़ेगा. ठीक है. अब क्या हो रहा है? So therefore, let's say these are different positions during the motion, right? So every time the ball is in front of him. Now imagine when he reaches here. Okay, when he reaches here, the string breaks. Okay, this string breaks here. So string breaks. So now, is there any tension between the? Is there any tension inwards? No. So now there is no force acting on this. Then what should happen? It should travel in the last direction. What is the last direction along the tangent? So what is the tangent here? Tangent here is this. Okay. So it will start moving along this direction. Okay. So, is it moving in circular path or straight path?
Straight path.
So he is okay, right? So he says now there is no force acting, so it has to go in the last direction due to inertia. But what about him?
You will see it moving
So
forward.
when it is moving in this tangential direction, this is still rotating. So he still sees the ball in front of him. Okay, the ball reaches here. His eyesight also is in the direction of the ball.
So it will still appear like rotation.
So what he feels, that ball is now going away from him. Okay, he feels the ball is going away from him, but ball is neither going away. It is just following a straight line path. So if the ball is going away, how will he explain this motion?
Circulatory still. It
Some
will
force is pulling it away.
Ah.
Second thing, when he told him, okay, there is a centripetal force acting inwards, so he does not believe, or to believe, so this is stationary for him. So what he said, there must be some equal and opposite force acting in this direction. To explain the stationary nature of the ball, he says the net force acting on the ball must be zero. So therefore, there must be equal magnitude of force. If he agrees to him, कि यहाँ पे centripetal force लग रहा है. So he says there must be also another force, due to which the ball is not coming towards him. तो बोल रहा ball और आके नहीं रहा इसके पास अगर centripetal force लग रहा है. Because he is not seeing the circular motion now. He is seeing what? Stationary. So to explain the motion of the ball to him, this observer, this force has to be conceptualized. The imaginary force. It is not a real force. This force is only coined to explain the nature of this ball, stationary in this case, and going away. Okay? So that means he feels okay. ठीक है मैं तो बोला ही था centrifugal force लग रहा है. टेंशन लगना बंद हो गया तो सेंट्रीफ्यूगल खींच के ले गया था. लेकिन है क्या सेंट्रीफ्यूगल? नहीं. Understood? So that's why centrifugal force is a fictitious force.
So centrifugal force will act in a direction directly opposite to it,
Yes.
or only in the direction of tangent.
To explain the stationary nature of this ball has to be equal and opposite.
Right, but it cannot change direction when the ball the
It is changing direction every time.
No, when the
When
ball
the
string
string
breaks.
when the string breaks, he sees it is anyway not there. So here also the centrifugal force direction is changing only now.
Okay.
Everywhere it is changing.
Okay.
But it is not there in reality. It is just the interpretation or explanation. Explanation of a particular phenomenon to certain observer.
Okay.
So this observer is also rotating. Then only. This force does not exist for the observer outside. Okay? Now, so is this a reaction to centripetal force?
Yes.
Hmm?
Yes.
Yes. So what is action-reaction force? What is the nature of action and reaction? What's Newton's third law?
Equal and opposite.
Equal and opposite.
Equal in
Equal and opposite.
So now see, look here, this is one body, the table is another body, okay? Now it is exercising its weight on the table. So weight of the duster is action on the table.
Reaction.
Where is reaction?
Normal reaction force are acting on the texture to keep it
Reaction is acting on the
table.
dust.
Yes.
Action is acting on the table.
Table.
Where is reaction acting?
On the duster, by the table.
Yes.
Now where are these forces acting?
On the board.
On the same ball.
No, the ball is acting force on the string, which is tension.
Tension is acting on the ball.
Yes.
And where is centrifugal force acting?
On the board.
On the ball only. So is the body same or different?
Same body.
And what about action reaction? Does it act on the same body or different body?
Different bodies.
So in this case, the force is acting on string, not on the body, right? So it can be one will be on string and one will be.
So the duster is exerting its weight on table. From where the weight of the duster comes?
From gravity.
From so that is, imagine string.
Right.
The source of its weight is gravitational pull.
Right.
Same situation. Here it is not gravitational pull, here it is tension. Physics is deep. Okay? So, what is the nature of action and reaction? Action and reaction acts on different bodies. Here the forces are acting on the same body. So, it is a case of multiple forces acting on the same body. So, it cannot be reaction. Cannot be reaction. ठीक है? समझ में आ गया? तो यही दो चीज नहीं समझ आती लोगों को कि imaginary force कैसे है and how it is not a reaction. So it is not a reaction. It is just very different force imagined to explain a certain phenomenon. That's it. Stop my role. ठीक है? So with this we have completed this chapter. Do you have any? This is the fourth hour.
Fourth session.
Third session and fourth hour.
Third session.
And fourth hour.
Yes.
So we have time. We can still give time to this chapter. If you have any numerical doubt, you can ask. And in the next class, I will be starting work power. Okay? Have you tried numericals yourself? Did you get stuck anywhere? Need help? All numericals you are able to solve?
Yes.
Shall we move on to the next chapter then?
Yes.
Yes.
Sure. Anybody has anybody needs help?
Does the C part and have any numericals?
No, there's nothing. Just go through it. If you need any help, I can.
Okay. Then no.
Go through questions in volume. Anybody following different textbook? Have you tried questions? You are able to do? You are able to do questions? Okay. So anybody who is following book other than Selena, if you need any help, please ask. Take your time. Take 5-10 minutes. If you are comfortable, then we'll go to the next topic. You all signed the attendance?
Yes.
No help needed? ठीक है. So बाद में देख लेंगे. अगर कुछ आया तो we'll see it.
Yes.
Is there any topic remaining to be covered in the other publication? So we have touched upon everything. Work, energy, and power. So, when we say work, right? Are you all working right now? Studying, right? Studying, right?
Yes.
So it is working. But it is mental work, not physical work. Okay. So here, when we say work, we are going to define the work as per physics or mechanical work. Right? So in physics, we say work is done when force acting on a body produces displacement. Okay. So, in physics, work is said to be done when force applied on a body displaces the body in its direction. Work is said to be done when force applied on a body displaces the body in its direction. So we can illustrate it like this. So let's we can call it AB. So this force was applied at A, and its position was A initially, and the force kept acting on the body till the new position. Okay, so it caused how much displacement? AB, which is S. So this is then what is the work done? So we define work as product of force times displacement. How is this displacement? In the direction of force. equal to L. Now, is it that always the displacement is in the direction of force?
Yes.
Yes.
Always.
Yeah.
When it is not.
Unless there's an external force acting on the body already, and the force applied on the
Yeah, I was talking about the forget other forces. When the
The
applied
work
force.
is not done. Work is not done.
So work is not done when the displacement is zero, like pushing a wall.
Yes.
When you push a wall, you're applying force, but is there any displacement? No. Or if you're standing with some load on your head, so there is weight on you,
but there is no work.
but there is no work done, right? So when somebody is like walking with some load on the head or carrying some load, it's not working actually, as per physics. Okay. So the question was, is it that the displacement always in the direction of force?
Displacement is already
Yes.
For example,
Like when we walk.
Huh?
When we walk. Yeah,
When we
applying a
walk.
force. Yeah, when we walk.
when we walk, so
Yes.
We apply a force backwards, but we go forward.
yes, in a way, but that is in the opposite direction, correct? We apply, so we are trying to push the ground behind, but the reaction of the ground pushes it forward. How do we walk forward? Due to the reaction from the ground. So whenever we are walking, we are pressing earth backwards. Earth throws us forward. That's how we walk. Okay. So that's action reaction. So give me some clear example where it is very obvious that the force and displacement are not in. I am applying force. Say for example, let's say this object. So when I am pushing, so force is applied here. This is also moving in the same direction. So now this is my travel bag.
Oh,
Where am I applying force?
when you are pushing an object up or down a hill.
Yes. So I am applying or I am pushing the object on some inclined plane.
Yes.
I am pushing it, but object is moving up.
Oh, अच्छा.
Okay. So these are familiar examples, right?
Yeah.
Traveling back, walking like this, force is like this, but displacement is horizontal. तो अब यहाँ पे क्या हो गया? So work done when force and displacement are not in the same direction. Okay. So one example is, let us say when you are pushing some object in on an inclined plane. Keep it here. You are applying a force in this direction. Right? So the object is moving up from here to here. And you kept applying the force in this direction. Okay. So then how do you calculate work in this situation? So what you
the force into the horizontal component.
so you have to take the, so either you take the horizontal component of the displacement in the direction of force, or you take the component of force in the direction of displacement. Okay. So let us name this. I will redraw it like this. This is force. Okay. And this is your displacement S. So the way, so this displacement, let's call this as A, this as B. So what is the displacement direction? Displacement in the direction of force. You draw the horizontal line, right? And then draw a perpendicular line. Okay. So then you can call it C. So AC is the component of displacement in the direction of force. What is it? AC is the component of displacement in the direction of force. Okay. So then you can take this angle as theta. Okay. You can take this as the angle theta. Or you can put K.
So the work done here will be force into AC.
Yes. So in this case, W is equal to F into AC. Okay. But AC has to be expressed in terms of S and the angle. The known quantities are S and angle. So what is the relation between AC and AB? Trigonometry. This is a right angle triangle.
It's cos theta.
Cos theta. So what is cos theta? AC upon AB. So AC is equal to AB cos theta. What is AC? AB cos theta. Since why so?
Because we have to do slightly more work to push it up the incline rather than AC.
So what is AC? This means AC is equal to AB cos theta. That's what we have written. Okay. But what is AD? S. So whenever the force and displacement are not in the same direction, then you have to either take the displacement component in the direction of force, which is S cos theta. You can also take force in the direction of displacement. So instead of this horizontal line, you can extend this line and then take the perpendicular of force on this line. Okay, so this you can take D. So dA is the force component in the direction of displacement. This you can take as theta. So AD and E. Okay, so you can take either of these two. So the other formula will become you can write F cos theta into S. You can get dA as what is this? dA upon EA is equal to cos theta.
Yes.
And EA is F. So you'll get F cos theta into S. Okay, both give result into same formula. So you can either take the force in the direction of displacement, or you can take displacement in the direction of force. Both will give you the same formula.
DA and EV can be stretched infinitely, or is that just for the sake?
No, we know how much force. It is a vector quantity. Say 5 Newton, 10 Newton, whatever. So we know. So the length of the vector tells the magnitude, and this is the direction.
So that DA will be equal to AB. Just not to scale.
dA will be equal to
AB.
no along AB. EA is along AB in the direction of displacement. See, AB is representing displacement.
But DA is representing force.
Yes, exactly. Just like here. FA is force. I mean, F is force. F is force, so you can put something CO. CA is force. Got it?
Okay.
So, or W is equal to F cos theta into S. This also results into F S cos theta. So you can get this formula in two ways, either by taking component of force along displacement, or by taking component of displacement in the direction of force, so that this definition is satisfied in the direction of force. Clear? So now let's write down the units of work. SI unit of work is joule. We don't write unit of work as Newton meter. Torque is written as Newton meter because Newton meter signifies a vector quantity. Torque is a vector quantity, but work is scalar. Okay, that's why we write work unit as joule.
But joule is Newton meter only,
It is Newton meter technically,
but without the direction.
it has no direction. So work being scalar quantity. Okay, that's has no direction. So unit of work and torque is same, but torque and work are very different quantities. Torque is a vector quantity, whereas work is scalar. Although you are getting it through the product of two vector quantities. So in vector algebra, you are going to learn about vector products. There are two types of vector products: cross product and dot product. Cross product results into product of vector quantity resulting into a third vector quantity. Whereas dot product results into product of two vector quantity resulting into a scalar quantity. So this is the dot product. So sometimes it is also written as W is equal to vector F dot S. So this dot product of two vector quantity resulting into a scalar quantity. And cross is written as cross. Here, when you are writing cross, it is not cross product because this is written as scalar. You understand? So this is multiplication. This is not cross product. Understood? This is not cross product. This we are writing force magnitude, displacement magnitude, and just multiplying them algebraically. Whereas if I write it like F cross S, then this becomes cross product. But work is not a vector. This will result into a vector. Hence, there is a definition of dot product of vectors whose final answer is a scalar. Okay, so wait till you start learning about vector algebra. I think it will be introduced to you in 11. So till then, just use this definition. Although this is also given somewhere in your book. Okay, cross and dot product. Somewhere in the outline it will be given. Okay, it's given in the footnote, etc. So it is extra, but you are not supposed to do this. Just this is enough. So this is SI unit. What about CGS unit? So basically, what is 1 joule? 1 joule is equal to 1 Newton meter. So 1 Newton is 10 raised to 5 meter is 10 raised, so it is 10 raised to 7 arc. Okay, so the SI unit is joule and CGS unit is arc. So this is the relation between 10 raised to 5 dyne and 10 raised to 2 centimeter. So dyne centimeter is arc.
So again, all
You want to
expressed
switch
in terms of gravity.
Switch off here. Vijay, AC का remote लेके आ.
All gravity
GF and KGF.
Sir,
KGF.
can Earth be expressed in KGF and GF?
GF
Yes.
all will be in GF Newton.
GF na?
Yes.
Newton is gram centimeter per second square. वैसे कर सकते हैं. It is switched off by opening that window. इसको बंद करने बोल रही है. सभी को लगेगा. Thank you. So is the concept of work clear?
Yes.
Okay. So now we'll discuss about positive work, negative work, and zero work. So I erase this. You should take down this short notes in your notebook. Have you noted it down?
Yes.
No. So now since W is equal to F S cos theta. So if theta is equal to 0 degree, theta is equal to 0 degree, then that is possible. Force and displacement in the same direction. Right? So theta 0 means displacement is in the direction of force. So this means cos 0 is
1.
1. Okay. So cos 0 1. So this means W is equal to Fs. That is positive. So whenever the force acting on a body displaces the object in its direction, the work done is said to be positive. Okay. So what is the example of positive work done?
Pushing a box on the inclines. No, 0.
Incline is 0
0
degree.
degree. Pushing a box.
Positive work done. So examples of positive work. So this work done by gravity, is it positive or negative?
Positive. Getting the same direction.
Force is gravitational pull is downward. Displacement is also.
Down.
So first example is work done by force on a falling object. Okay, because the object is experiencing mg and it comes down. Okay, so what is the displacement? S. So S is the general symbol for displacement. In this case, it is height. Okay, displacement is h. Generally, horizontally we write S, but vertically we write h. Okay, now tell me, I'm lifting this object upward. Is the work done by me positive or negative? Against gravity. I'm lifting it against gravity.
Says 0. 0, you're only holding the object. So it's
Lifting.
Lifting.
Is it positive or
Positive.
positive? No, I'm lifting it against gravity. So it is positive. So I am doing
You
the
are
work,
applying force.
I am applying force upward. Okay? And the displacement is also upward. In the same situation, what is the work done by gravity? Negative. Okay? In the same process, work is done by some force. So depending upon which work is being asked, I am saying work done by me is positive. But in the same situation, work done by gravity is negative. Be careful in the question. Right? So a person lifting an object against gravity does positive work. Okay, so like in the object is lifted up to certain height. So what is the force applied? The force applied has to be at least equal to the weight of the object. Okay, so this is the weight is gravitational force. So when you are lifting, you are working against the gravitational force, but the work done is asked of a person. Person is applying force or effort in the upward direction, displacement also in the upward direction. Okay, so what is the work done here? In this case, what is the work done? mgh. Here also it is mgh. Next. Easy. Okay, what if theta is 180 degrees? So let's say theta is 90. 0. Or
Zero.
so in this case,
Cos 180 is minus 1. Naturally.
zero working.
To the reach of the 10.
Yes. So when theta is equal to 90 degree,
Cos 180 minus.
cos 90 is 0.
Zero.
So whenever the angle between the force and displacement is 90 degree, then the work done is 0.
Zero.
What are the examples?
One.
So if the force is like this and the displacement is like this, then it is 90 degree. Wall में कहाँ 90 degree?
The one is 90 degrees.
You're pushing the wall, the force.
अच्छा है.
ये वाला एग्जांपल बताओ. Force में और इसमें 90 degree. Examples दो. So zero work done बहुत cases में होता है. एक तो angle 90 होगा या फिर displacement 0 होगा. वो भी है.
Pushing a box and नहीं पर तो दूरी है ना.
So a person walking with some load on his head. ऐसे he is walking like this. तो क्या हो रहा है? Displacement कहाँ पे हो रहा है? इधर. और उसका weight किधर है?
No.
90 degree हो गया. So it's not doing any work. Means gravitational force is not doing any work. ठीक है? What work he is doing?
Zero.
Zero.
Against some force, frictional force के against में तो कर रहा है.
तो negative.
हाँ?
Negative was.
Yes, negative हो रहा है. Displacement हो रहा है लेकिन frictional force तो लग रहा है ना उसमें. तो डिपेंड करता है क्वेश्चन में कौन सा फोर्स पूछा है. सेम सिचुएशन में सेम प्रोसेस में one of the forces might be doing work. So be careful. The work is being asked about what force. Yeah? So examples written. Examples of zero work. Yeah. When person walks with some load on his head, the work done by gravitational force is zero. ठीक है. और एग्जांपल बताओ क्योंकि नीचे ग्रेविटेशनल फोर्स लग रहा है which is 90 डिग्री है ना. What else? during uniform circular motion. At every point, the displacement is along the tangent, and the force is towards the center. So work done by centripetal force is always zero. So for any object in UCM, work done by centripetal force is zero. Okay. So this is zero work done due to angle 90 degree. So zero work done में और भी cases हो सकते हैं due to theta equal to 90 degree. Okay. Work done is zero if displacement caused is if s equal to 0. F not equal to 0. ठीक है उल्टा लिखना मतलब there is some value of f but no displacement. ठीक है some force is applied but displacement is 0. So what is this example? Pushing a wall. So these are two possibilities of zero work done given in your book. There is another possibility. Force zero, displacement not zero. Is it possible that an object is moving without any force applied on it?
Inertia. Sir, वो inertia वो एक main example.
Inertia में भी तो friction तो लगेगा ना. नेगेटिव वर्क हो जाएगा लेकिन जीरो वर्क नहीं होगा वो.
तो fully walking वाला horizontal है.
हाँ हाँ.
Fully walking वाला horizontal.
Fully say person. I mean everywhere book says fully. I am using the word person. With some respect. ये book वाले ने fully क्यों लिख रहा है? Fully walking on the road तो क्या हो गया उसका?
The work done will be zero.
Why? By which force? Gravitation. वो तो हमने किया है ना. That we already covered. लेकिन अपने को क्या चाहिए?
Force नहीं applied है, displacement.
There is no force, zero force, but displacement happening. Frictionless surface. Any body moving on a frictionless surface. Huh? Possible, right? अगर frictionless है,
Space, aircraft.
हाँ जहाँ पे भी friction नहीं है, like snow में एक बार धक्का दे दिया उसको.
So but friction cannot essentially be zero, right?
See, when we study, you know, we do a lot of approximation. Approximation ही करते हैं हम.
So we'll consider it negligible.
So we are saying, negligible. It's a very smooth surface.
Atoms,
What atoms?
any atom. Force applied is zero. But
On atom? Who says that?
any particular.
Any free atom, isolated, अलग है सबसे तो उसमें भी assume करना पड़ेगा. यहाँ पे भी we are assuming frictionless surface. Do we have frictionless surface? 100%.
Only vacuum.
Only vacuum में कर सकते हो, right? तो एक बार गया तो वो it will keep on going, right? So वो है नहीं तुम्हारे बुक में एग्जांपल, वो मैंने डिस्कस किया है. कभी अगर आ गया तो याद रखो, ठीक है? So work done is zero. Zero for if f equal to 0, s not equal to 0. like body moving on a frictionless surface. तो फ्रिक्शनलेस सरफेस पे डिस्प्लेसमेंट हो रहा है लेकिन फोर्स नहीं, तो भी वर्क नहीं हो रहा कुछ बॉडी, यानी सिंस फोर्स है ही नहीं तो वर्क ही नहीं, क्योंकि वर्क होने के लिए क्या चाहिए, एफ इज जीरो। तो तीन तरह से वर्क जीरो हो सकता है, F0 और S0 और थीटा 90, ठीक है, एनी वन कंडीशन कैन गिव वर्क डन एज जीरो। नाउ द लास्ट कंडीशन इज नेगेटिव वर्क। So in this case, force and displacement act in opposite direction. That is, theta is equal to 180 degree. तो cos theta कितना हो जाता है, -1. Cos 180 is -1. ठीक है, थीटा 180 डिग्री cos, तो इसमें वर्क डन बाय फ्रिक्शनल फोर्स ऑलवेज, है ना, तो इसके इसमें फोर्स इधर लगता है, डिस्प्लेसमेंट इधर होता है, तो द एंगल इज 180. एग्जांपल, work done by frictional force. Frictional force by definition is always opposite to the direction of motion. तो वो हमेशा नेगेटिव होगा। और कौन सा? और एक एग्जांपल बताओ। In this situation, which force is doing negative work?
Gravity.
Yes. Gravitational force does negative work on upward moving body. Gravitational force. On body moving upwards. Okay. So today we have covered work. Next class we'll talk about air.
भाई बहुत दिखने वाले it doesn't hurt anymore. ये टिश्यू